Hey geometry students, what's happening? Mr. Zacek back here with you, and we're cruising through Unit 3. We're in Lesson 6, and we're going to look at slope and the equations of lines, and hopefully a good bit of this is actually some review from things that you've done in algebra, and we can move pretty quickly through it here. But first thing is, the slope is the ratio of the vertical change to the horizontal change between any 2 points. And we have a slope formula. I have a song that goes y2 minus y1 over x2 minus x1. It's the rise over run. It's the slope formula. y2 minus y1 over x2 minus x1. It's the rise over run. It's the slope formula. So obviously it's a formula that we need to know. And we have slopes that are positive. They're going up from left to right. Slopes that are negative, it would go down from left to right. And vertical lines have an undefined slope, and horizontal lines have a zero slope, so there's no change happening there. Sometimes you may have seen this before. I call it the slope house. So if we draw a little house, okay, positive, negative, zero, and undefined. And one of the things that I like to put on my slope house is a little dormer. So that helps me understand, like, if we're going positive, I can go up and to the right or down and to the left. And negative, I can go down and right or up and left. And again, it's the rise over the run, or the change in y over the change in x. Okay, so find the slope of the given line. Well, when we have it on a graph, we can just do m is the variable we use often for slope. We can just use the rise over the run. We can kind of count it out. So let's draw it in here. What's our rise? 1, 2, 3. We count it out. And our run is here. So the slope, or the letter m, of this line would be 3 over 2. Okay, and it's positive because as you move from left to right, the line is going up. All right, now, so we had that. That's from the graph, but when it's not given to us in a graph, sometimes it's a little simpler to use the slope formula. So we start off, we label our point x1, y1, x2, y2. Okay, here's our slope formula. Slope is y2 minus y1 over x2 minus x1. It's the rise over run. Anyway, it's the slope formula. So negative 3 minus 2 over x2 minus x1. Always put that second negative number in parentheses. Negative 3 minus 2 is negative 5. 7 minus negative 1 is 8. So the slope here would be negative 5 over 8. All right, let's go ahead and do one more here. Start off by labeling our point, x1, y1, x2, y2. Okay, so the slope would be 6 minus 2 over 1 minus 1. So 4 over 0. Now we can't divide a number by 0. That is undefined. So here the slope is undefined. And if we were to graph that, we would find that this is a vertical line. In other words, or another way of thinking about it is the x value does not change. You see what we have here? We have 1 and 1. So there's no change in x. That's when you have a vertical line. All right, so 3 different equations that we have for it. We have the slope-intercept form, y equals mx plus b. Sometimes we need to remember that m is slope, so I just say slope. Like, you know, give me some slope, because that m represents the slope, and the b value is the y-intercept. So we're going to use that equation if we know the slope and the y-intercept. All right. And then equation of a line, point slope form. The way I remember that is y minus y1 equals m times the quantity of x minus x1. Y minus y1 equals m times the quantity of x minus x1. Y minus y1 equals m times the quantity of x minus x1. Okay, so we're going to use that when we know a slope and we know a point. And then standard form is ax plus by equals c. Key here with standard form, there's no fractions for a, b, and c. And standard form is one we would use one of those other two reasons, and then we would convert it into standard form. All right, but we don't want any fractions in that case. All right, couple special cases. When you have a horizontal line, that is y equals a number, and you can see from this diagram here that the reason it's y equals is every point on there, y equals 5. Every point on there, y equals 2. Every point on here, y equals 0. Every point on here, y equals -3. And then for a vertical line, we've got x equals a number here. Okay, the trick or the common error is to recognize that the common error is here and here, okay? And so the x-axis equation is y equals 0. The x-axis, the equation for it is y equals 0 because every point along that axis, the y-coordinate is 0. All right, and then the same thing up here for the y-axis, the equation is x equals 0. And usually people are good, but that confuses them. So that's the one we gotta be aware of. Y is equals is a horizontal, x equals is a vertical. All right, so let's roll through some of these. Write the equation of a line with a slope of 3, slope, and a y-intercept of -5. Well, we're going to use this formula, y equals mx plus b, okay, because we have those two things, and it's just simply a matter of substituting in. So y equals 3x minus 5. We could write plus -5, but that's just transfers into -5. All right, so that's the most, basic or simplest. You're given the slope, you're given the y-intercept, and you would put it in here. Just another way this question can be asked is instead of the y-intercept, it might tell you that it goes through the point 0, -5. Well, that point is the y-axis or the y-intercept. Okay, write the equation of a line that passes through -1, 5 and has a slope of 2, expressed in point slope form and slope-intercept form. Okay, so we have a point. What we're given is a point, and we're given the slope. And so we want to start off here by using the point slope formula. And the point slope formula is y minus y1 equals m times the quantity of x minus x1. Y minus y1. Now that one, it's hard to only sing it once. Okay, so the point is going to be x sub 1, y sub 1. And so we do y minus y1, so y minus 5 equals m, which is 2, times the quantity of x minus -1. I like to call this a cleanup step. I just want to clean up the signs before I do anything else. So that'd be x plus 1. Okay, you don't have to do that, but it's often is helpful. All right, then we're going to, so this right now, that is the equation in point slope form, but we also want to write it in y equals mx plus b form. So let's carry it a step further. Y minus 5, we're going to distribute 2x plus 2, and then we're going to add 5. and so y equals 2x plus 7. That's the same line, just written in a different form. So this would be what we call slope-intercept form, and this is point slope form. If they don't specify, you can just leave it in point slope form, but if they specify slope-intercept form, then obviously we need to carry it out to that point. Okay, number 6, write the equation of a line that passes through the points expressed in point slope form and slope-intercept form. Okay, well, what we have, or what we're lacking right now, is we don't have the slope, but we know the slope formula. So the slope formula is y2 minus y1 over x2 minus x1. It's the rise over run. It's the slope formula. So let's go ahead and find the slope. So that would be 5 minus negative 1 over 3 minus negative 2. And we put that second number in parentheses if it's negative. 5 minus negative 1 is 6. 3 minus negative 2 is 5. So 6/5. Now we have the slope and we have a point, so we'll use the point slope formula, which is y minus y1 equals m times the quantity of x minus x1. Y minus y1 equals m times the quantity of x minus x1. Okay, it does not matter which point you plug into. The mistake that people make is they plug both points in. We're not plugging both points in, so just for the sake of consistency, let's use this point right here. So y minus negative 1 equals m, which we just found to be 6/5 times x minus negative 2. Again, if you wanted to plug the 0.35 in, you could. It would give you the same answer. So the cleanup step, this will be y plus 1 equals 6/5 times the quantity of x plus 2. All right, so this is our answer in point slope. But it says also slope-intercept form. So we're going to distribute the 6/5. So we get 6/5 x. It would be, when we do 6/5 times 2, that would be 12/5. Okay, we're going to subtract 1. Y equals 6/5 x. All right, and 1 is really 5 over 5. So it's like you're subtracting 5 over 5 would be 7/5 would give us this value down here. Okay, so this one is a little bit more involved, but it's also one of the ones that we more commonly see. This type of question, number 6, it's going to show up on a bunch of problem sets. All right, so we got a few more things that we're going to graph here. All right, graph the equation 2/3 x plus 1. So when we have our graph here, 2/3, our value of b is 1, we always start first with the y-intercept, okay? And then I think of this as our slope house. We've got a positive slope. So here's my kind of positive dormer. I'm going to go up 2 and to the right 1, 2, 3. 1, 2, 1, 2, 3. Or I'm going to go down 2, 1, 2 to the left 3. Down 2 to the left 3. All right. And then I would take a straight edge. I draw this out, okay, label the line, y equals 2/3 x plus 1. Okay, now the question is, does it go through 9, 7? Well, I can't see that here on the line, so what I'm going to do is this is an x, this is a y, and I'm going to substitute into the equation here. So does 7 equal 2/3 of 9 plus 1? That's my question mark. Is this true or not? So 7, 2/3 of 9 is 6 plus 1. 7 equals 7. Okay, so that's true. true. So therefore, 9, 7 is on the line. So we can check that algebraically to see if it's a solution or if it lies on the line here. Okay, now graph the equation. All right, there's a couple ways you could do this, but what I'm going to do in number 8 here is I'm going to convert it to slope-intercept form. So I'm going to distribute that negative 2x minus 6, then I'm going to add 3, and I would get y equals negative 2x minus 3. So I'm going to have a slope of negative 2 and a b value of negative 3. We can write the negative 2 over 1. So we start on our y-intercept. We start down here at 3. And now the slope is on the negative side. So that means I'm going to go down and right or up and left. So down to the right one, or up to and to the left one, up to left one, up to left one, up to left one. Okay, so we have this one here. We can label that with our original equation, y minus 3 equals negative 2 times x plus 3. All right, so the point 410 clearly is not on the line. Okay, now I just can tell 410 is going to be some point, up here. So 410 is clearly not on this line. To show you that algebraically, if we substitute it in, does 10 minus 3 equal negative 2 times 4 plus 3? Okay, so 10 minus 3 is 7. Does 7 equal negative 2 times 7? 7 equals negative 14 is false. Okay, so that's how we could tell algebraically. All right, now last two, write the equation of a vertical line that passes through 2, 4. Okay, so a vertical line is a line that goes up and down. And here's what I want to point out to you with this is that, so we've got 2, 4, we've got 2, 3, we've got, 2, negative 3. So this is x equals 2 because everywhere along that line, the value of x equals 2. All right, and then write the equation of a horizontal line that passes through the point 4, negative 3. So 4, negative 3. Well, a horizontal line, it's like looking at the horizon. It's going to come across here. So this is going to be y equals negative 3 because every point on that line, the value of y equals negative 3. Okay, so we covered a lot. I went pretty fast. If you have to go back and listen to some of that, please do. All right, but a lot of this is things that we've done in algebra, so I want to do it, but it does show up quite a bit in what we do. So you're going to see it a lot in problem sets. So let's make sure we get all these things ironed out and ask and keep on asking. Okay, good luck.